Welcome, everyone. I'm your host, Mary McLeod Jones, and I'm joined by Jack Armstrong, president of Acumen LLC, and we'll be acting as the host and moderator for today's programming, which focuses on structural sheathing innovations and code updates. These two programs equal 1.5 AIA learning units. The first program is a 30-minute nano course worth 0.5 HSW credits focused on reversible structural insulated board, or SIB. That'll be presented by Darcy Overby and Josh Elliott of Barricade Building Products, followed by Jay Crandall, PE, presenting prescriptive wall bracing and the 2021 IRC. That's a 1 credit unit course focusing on wall bracing provisions of the 2021 International Residential Code and the steps to meet these provisions. We will register AIA member attendance for all of those who included their member numbers in the registration. If you haven't, please put that in the chat and we will take care of that. All attendees will receive certificates of completion for self-reporting professional purposes as well. We want to remind you all that you are muted currently. If you have questions, and we hope that you do, our presenters will be answering those at the end of the programming. But please add them in the Q&A function on your screen and not in the chat area. This will allow everybody to see the question and vote them up or down so that we'll be able to answer the most relevant questions. Again, we'll be taking all of those questions at the end of the program. But before we go any further, I want to take a moment to thank our sponsor of today's program, BASF, the makers and inventors of Neopor GPS, that's graphite polystyrene rigid foam insulation. It delivers maximum efficiency, cost effectiveness, and the lowest embodied carbon of any rigid foam insulation. We'll share more information about Neopor with you in the links on the downloads, and also at the end, you can ask questions about Neopor as well. Now, I want to introduce our first speaker, Darcy Overby. She's the National Sales Director of Barricade Building Products, and she's going to kick this off with this really great nano course about the advantages of reversible graphite structural insulated board. Darcy, take it away.
Thank you very much, Mary. Good morning, everybody. Thank you for being here. As Mary said, I am Darcy Overby, the Director of National Sales here at Barricade.
Oops.
So as you know, as Mary said, this course will be accredited, an AIA accredited course here. You will get credit. So there are quite a few advantages to reversible graphite structural insulated board, and you'll hear me refer to it as SIB or SIB board throughout this course. So a few advantages are it provides exterior continuous insulation for your projects. It's going to provide moisture management. It will increase durability and environmental performance and increase project efficiencies on your job overall. After we're done here today, you'll be able to describe what is SIB board. You'll be able to explain the benefits this type of product provides. You will understand how it meets different code requirements, as well as be able to share information on how it can be used. So what is it? What is reversible graphite structural insulated board? So here is a nice cross-section of what the product is and what it's made of here. So on the very right-hand side, you're going to see the water, the first layer of water-resistant barrier and air barrier. Then sandwiched in between in the middle there, you see that GPS, or that graphite polystyrene insulation. And that's very important that we note it's the graphite polystyrene, because This type of foam, this insulation does not off-gas. It holds that R value over the life of the product, which is very important. And then on the left-hand side there, you're going to have the engineered structural panel. So that's going to be the shear component of the system. And then on the other side of that, there is another water-resistant barrier, an air barrier, and that's in the form of a poly coating on that engineered structural panel. So that's the system. That's what makes up the system here. So the product as a whole has multiple different system efficiencies. So the first and most important here, so it is a 4-in-1 code compliant product. So with this one panel, you're getting your structural sheathing, your structural component for the wall. You're getting your air barrier component. You're getting your weather barrier component and an added R value all in one panel. It also helps meet your continuous insulation requirements on the building. It has the long-term R value and a low product carbon footprint. It's lightweight and dimensionally stable, so one person can handle a panel of this product. And it's reliable. There's extensive testing that's done for these panels, as well as it has a nice, straight, smooth install. And it produces less waste overall and takes less labor to actually install. So with a system like SIB, you're going to be able to increase your project quality and your profit for your customers. So their projects will be able to be done quicker, which will allow them to have access to revenue and provide quicker closings on the projects. So this one panel reduces the amount of steps just because it's so many products in one. It reduces the amount of steps around the building so they can get more projects done per year just because it's quicker to install. And we get asked a lot, how does a structural insulated board differ from just a standard wood structural panel such as OSB or plywood? And there are a lot of differences, but I'm just going to talk about a few of the main ones here. So the first, again, is that addition of that water resistant and air barrier to both sides of the panel. So you're going around the building once instead of going around multiple times with multiple products, which can be misinstalled. More products lead to more misinstallations. The additional products can be costly. And again, that time, you save time with just this one. Second, this panel provides superior racking resistance. So again, it's an engineered panel that replaces an OSB or plywood. So it'll provide some superior racking resistance. It has quality control that oftentimes can't be seen with plywood and OSB. And last, it can be less than half the weight of a standard wood structural panel. So again, one person can easily install it and handle it themselves. And with that, I'm going to pass it over to Josh Elliott, our Director of Product Management.
Hi, everyone. So GPS, if you're not aware, is EPS with graphite added into it. It was patented by BASF, and the graphite improves the performance of over a normal EPS. It adds roughly 25% R value increase over EPS. And it meets all of the same normal standards of EPS. So if you're used to working with EPS, GPS is the same, it just provides better properties. So you can go to the next slide. And in that, it provides more R value per inch, whereas EPS is a 3.6 per inch, GPS is 5, matching XPS. It is vapor semi-permeable, so if water were to get in there, will eventually has a way to escape, and it provides the lowest embodied carbon of any rigid insulation. And it's not relying on blowing agents like an SPS to help provide that R value that dissipate over time. Go to the next slide. So one of the unique things about an SIB product is that it is reversible. Traditionally, when you're installing foam on a home, the foam is facing outward. You can still install a SIB product like that, but you can also put it with the foam in towards the studs, which gives you a hard shell. The structural sheathing is on the outside, which makes a very nice smooth wall, great for siding installations, but it also just helps during installation and before the siding is on. Yeah, you're not going to overdrive fasteners through foam with the sheathing out, and it protects if you're installing a window on the second floor and somebody sticks a ladder up there. You're not going to take a chunk out of the foam with the structural sheathing protecting it on the outside. Next slide. And I guess what we're trying to talk about here is it's an easy install. It's going to install with a traditional nail gun or staple gun, just like an OSB would. So people that are used to installing OSB, they can install this the same method. But in the same time period of putting normal OSB sheathing on, you're going to get your CI and water resistant barrier all in the same time frame. We can go to the next slide. Yep. And so, as we've said, it does meet all of your requirements. So everyone knows the new energy codes are coming, and they are going to require extra insulation in the walls. So you've got that, and with continuous insulation, you're providing, you're not going to get the thermal breaks where you can see the studs and thermal transfer there. It does provide air barrier properties. You don't need to put house wrap up. It meets all your WRB properties and your structural sheathing. So it really does save you time and provide a 4-in-1 product. We can go to the next slide. So as I stated, the energy codes are coming. There's currently 13 states that are under review right now, looking to adopt them, and even some localities, I know metro areas that are adopting them already, trying to get ahead of the state, because everyone's aware with either extra insulation in the walls or the continuous insulation, it's coming. It provides a better home. It's more airtight, more energy efficient, everything that's people are looking for. If you're trying to get your HERS rating up, this is a great way. And as you can see, we do offer it in an R3 and an R5. And with the R5, you basically have the whole country covered with the new 2021 energy codes being adopted. We can go to the next one. It does require less material. So as Jay gets into the prescriptive bracing methods here, there are TERs, technical evaluation reports, for the SIB products. They do have shear values if you want to design your own shear wall, but they also have what's called an equivalency factor, and that's your equivalency to an OSB panel. So if you're following the prescriptive method and you look up in your table for your building, say you need a 10-foot required bracing length on a wall. If your equivalency factor is 0.8, you multiply those two, and now with an SIB type product, you only need 8 feet versus the 10 feet in the prescriptive method. The other thing, corners are always a tough sealing proposition. That's generally where you can find a lot of air leakage. With the SIB guard product, it does seal that off. The continuous insulation folds around, so there's no break in the insulation, your air barrier, or water barrier there as well. We can go to the next slide. There is SIB is manufactured under a strict quality control process in-house where it is tested constantly. But there is also third-party testing where it's been tested in full 23-foot walls, 4x8 walls, perforated, portal frames for, say, a garage door. During this testing, every stud has load cells under it. There's deflection is measured. We know where every pound going in and where exactly it comes out. And to prove that, you can go to the websites for the TERs. They have PE stamps for every 50 states, just to add a little more sorry, just for comfort reasons, proving that you have nothing to worry about there. Next slide. Ways to specify this are asking for a SIB product with GPS, so you get the better R value over an EPS product. There's the wrappable corners, as you can see in the picture there. It ships flat and is easy to store on job sites, but folds up with our fiber hinge, making a nice continuous insulation there. And you still do need to tape seams on it and flash windows as normal. And it does come with a 30-year warranty. All right. And that is the end of ours.
Thank you, Josh and Darcy. That was great. So next, we would like to go right into our next program, which is prescriptive wall bracing in the 2021 IRC with Jay Crandall, PE. A little about Jay. Jay has more than 30 years of experience in building technology research. Many of you are already familiar with his work. He's conducted benchmark studies to address structural, energy, and building science challenges, and has worked to propel innovative technologies into codes and consensus standards. Jay is also a principal of Applied Building Technology Group, or ABTG, an ANSI-approved standards development organization. And so, Jay, take it away.
All right, thank you, Mary. I appreciate that, and I'm glad to be able to meet with you all today. I hope you gain a lot of benefit from what I'm going to share with you. There's a lot to talk about in wall bracing, even just prescriptively, setting aside all the engineering procedures and stuff that went into that. So we'll see if we can get through it all. And my goal today really is to give you a feel for the code and what you need to do and what the possibilities are. The technical stuff comes with practice and applying it. But if you can get a feel and know what's there and what to expect and how to apply it in a way that kind of makes it efficient for you to do so, that's what I'm hoping we can get out of this presentation today. So first we'll just cover some preliminaries and some basic concepts so that we're all on the sort of the same fundamental page as to why we even are concerned about wall bracing. And then we'll get into the nitty-gritty of the IRC wall bracing provisions. And then I'm going to walk through sort of a step-by-step accounting procedure. That's sort of the way you would want to apply these so that you're documenting your compliance and making decisions in a sequence that probably is most efficient and would allow you to sort of optimize or make a better decision at a certain stage when it's appropriate to do so. And then I'll talk about some additional resources, some that are available online free, even calculators, the new calculator that implements these provisions. And then as I understand, there'll be a follow-up presentation, then we'll have some Q&A. So sort of a little bit of background on me. I I've been involved in structural research, energy, and building science. I kind of got into the energy and particularly the building science stuff from my structural background because I was worried about protecting my structures, and wasn't trusting what was in the codes at the time. So got involved in a lot of structural research and building science research, and the provisions for wall bracing that are in the IRC now were in part based on research I had done on whole buildings and taking engineering technology to the level of being able to predict a whole building system and then reducing that knowledge down into some prescriptive provisions. And I worked with an ICC ad hoc committee to bring that technology into the building code. And on the moisture side, also the provisions that are on the code related to insulation ratios, and how you determine your U factors or your thermal performance while also balancing the moisture performance. There's new vapor control provisions in the code that I've been deeply involved with. So all of this stuff actually fits together. Decisions you make on your structure and how to do it actually affect other performance attributes that you need to be concerned about, like moisture control. So that's the beauty of some of these products that are becoming multifunctional, because they give you all of that in a package. And in many ways, it simplifies the decision making and compliance with the code. But that's another story. Let's focus on wall bracing, and let's jump right in. So preliminaries, the wall bracing provisions in the code, since I think it was when we worked on that in the 2009 edition, and it's been sort of refinement since then, but the big change was in 2009. We did a complete overhaul of the bracing provisions to catch them up to the 21st century, instead of, like pre-war housing styles and stuff. And the old bracing methods were simple, but so were the homes, and they were small, and it just worked. But with the newer large homes, large open spaces in the homes, there was a lot of redundancy in the building that had been removed, and we were pressing the limits of good performance. And so that was the genesis of that. But to address that technically accurately, and to also provide flexibility, lots of different ways of doing it, so you're not prescribing only one answer in the code, which would not be fair or very cost effective. There's a lot of information in the code, a lot of options. In fact, it's 60% of your wall framing chapter 6 in the IRC. 60% of that, a little better than that, is devoted to wall bracing. So you must know this to use it proficiently. And one of the sort of the fallacies is that there's a simple solution in there. There's no silver bullet, in the sense that no matter what product you use, no matter how strong it is, you have to use it in the right amount. You have to install it the way that it was intended to be installed. The bracing panels need to be of the correct width or configuration to be able to actually provide the resistance that's needed. And so there's a lot of rules that need to be applied, and they're applied to every single bracing method. Now, the bracing methods may have different properties, and the rules have different values assigned to them for different products, but they're all based on the same principle. So if you use any of the bracing methods correctly, you get a building that has equivalent overall lateral capacity, which is our goal. And then the code doesn't cover all possible bracing options. It couldn't possibly do that, although it has a lot. There are proprietary solutions. And the code, while it focuses on commodity solutions, sticks and bricks and things, the real, it can't stifle innovation by not allowing alternatives. So, you just learned about one alternative that's out there that is an alternative, a bona fide alternative bracing method that can be substituted into these provisions. Doesn't need an engineer to apply it. It's actually evaluated in a way consistent with these commodity materials, so that it can be just plugged into the prescriptive bracing code. The code does not provide solutions covering all conditions of use. In other words, if you're in South Miami and Hurricane Central with very, very high design wind speeds, it's not that these systems can't be used in that application with the right design. The scope of the code is limited to lower wind regions, sort of moderate hurricane down to sort of, what you would consider a normal wind hazard. Same thing with earthquakes. There's certain range of conditions it's designing for, but the most extreme hazards like near fault conditions in California or Alaska, you're going to need an engineer to apply it, just as you would any bracing material. There's design values, and then there's also prescriptive guidance on how to use it if you're not an engineer. So that's the preliminaries, basic concepts for code compliant bracing. We'll just answer two questions. Why is bracing needed, and when should I consider doing that? And so the main reason it's needed is to control the risk of building collapse. And obviously that's a life safety concern. Some examples of the characteristics of a building that factor into how much bracing you need to resist a load is, the plan size, the number of story and story height of the building are going to affect both wind and seismic load on a given story level. The roof pitch and height and shape will affect the wind load on the building. There's actually an optimal roof slope aerodynamically that would minimize lateral loads. But if you go too low a slope, then you increase your uplift load. So there's sort of an art to building configuration, and minimizing your structural loads as a means to be more efficient in your building construction. And then seismic, similarly plan size, your number of stories and story height obviously govern the mass of the building and its inertial response to ground motion. And then the weight is a big issue of materials. So depending on your cladding materials and things, roofing materials, if you're using heavyweight materials, you may get kicked into engineering or some more stringent bracing requirements even in the prescriptive code. So just a heads up on that. The other thing that varies is the hazard itself across the country. So this is a map that sort of combines both seismic and wind hazard. The seismic is your contoured colors across the country there. The red and being the high areas, the green being and yellow being sort of moderate, and then the blue and light color being low seismic. The IRC provisions cover everything except for the reddest colors there, and the wind provisions cover pretty much all. You only need to check wind bracing up through the yellow colors, as shown here on this bar in the IRC. So by meeting wind bracing in those zones, you've covered your seismic. You don't need to do a separate check for seismic bracing and see which controls. That's one advantage in the IRC's bracing provisions, is they don't make you do a double check where you don't need to. So in most of the country, really, 3/4 of it roughly, doing just the wind bracing check in the IRC is all you need. And then you can see here the coastal areas where that's you start to enter into the hurricane prone region. The rest of the country, the wind speeds might vary, design wind speeds from something less than 90 miles per hour to 115, depending on where you are, but that's considered a fairly low wind region. Before we talk about bracing in detail, I've been to a lot of hurricane and earthquake events, but particularly hurricane events and some tornado events, and done scientific random sampling of buildings, documentation of performance. And probably the biggest failure you see is wind uplift. Rarely is there a bracing failure unless there's major non-compliances with very little or no bracing, same in seismic events. But for wind, it's the uplift that gets you. And oftentimes the uplift, when the building is uplifted and then moved, like shown in this picture in a full-scale wind tunnel test, it looks like in the end that, well, maybe the bracing wasn't enough. And it was really the uplift load path. Once that fails, it doesn't matter how much bracing you have. So this uplift load path, whether you're using fasteners that are designed to increase the uplift capacity of your framing joints, or using separate brackets and straps, you need to comply with that in the code. And there's provisions in the bracing section to make sure that connection is made, because without that connection, you can go through all the bracing provisions and that will do you no good, because this will be the weakest link. Okay, so when should I consider wall bracing? As soon as possible. It can affect design decisions, maybe tweaking a window location if you're able to do early in the design thing and still keep the the architectural design you want, or maybe altering what you do on one wall versus another. It's easy to do at this phase, and then it makes compliance much easier. And particularly if you're doing a model plan that's going to be used repetitively, this fine tuning as early as possible during the design stage is extremely important. Of course, you can kind of get some of that in the back of your mind as you've applied the bracing provisions to get used to this. So as you're doing more of an architectural design, those things are in the back of your mind. It can really save you some headache down the road or potentially in the field to have those things all ironed out on your plan. And the code itself actually, if the building official requires it, but I think it's a good practice. The braced wall lines should be identified on the construction documents for the framer to make sure everybody's on the same page and we don't have a major, error in a building plan. And believe me, they do happen. And having them on the construction documents is your only good hope, basically, of making sure it's done right and giving the inspector something to actually look at to confirm it. So we're going to go down through the nitty gritty of some of the wall bracing stuff. We'll look at, what is a braced wall line? That's sort of the main element where bracing goes, and the wall lines of the building that are declared to be required to be braced wall lines. There's flexibility and there's an art to what you call braced wall lines. You may need an interior wall line, you may not. And then braced wall panels are what you put in those wall lines. They're actually segments of wall. It doesn't have to be a panel material. It could be a lead-in brace or whatever product or methodology you're using, but there's got to be a segment or a panel of the wall that actually meets the requirements to provide bracing in the braced wall line. We'll look at the minimum required bracing length, then to get the resistance to shear load from wind or seismic that's needed in a wall line, depending on its location and how far away it is from other braced wall lines that are sharing the load that comes to it through your floor and roof diaphragms. And then we'll look at braced wall line construction methods. There's a lot of them in the IRC, and each one has different installation conditions that need to be met. We'll look at minimum length of the individual panels depending on the nature and properties of the panel. You may need to have a minimum 8-foot length, whereas another panel could have a minimum 4-foot length to be qualified as a brace panel, or 3 feet, or maybe even down to 2 feet. So it depends, and those are all criteria you need to meet based on the bracing method you're using. Narrow brace panel methods like portal frames or garage portal frames, where you've got very little wall, but you still need bracing capacity. There's methods in the code for that. Then there are detailing requirements, like what do you do at the end of the brace wall line to anchor it? Because this is conventional construction. There may not be a hold down bracket, but how do we make sure we detail this redundant, repetitive framing system to provide the hold down restraint necessary just through the framing and the corner condition itself, like a corner return panel, to provide restraint so that you can get the shear capacity out of the wall line. So there's detailing requirements there, and flexibility, how you do that. Then we'll talk about connections between the floor and roof. You've got to be able to transfer the load out of the floor and roof diaphragms into the walls so that they're go to the resistance down to the foundation. So those load paths need to be there and properly attached, floors to walls, brace wall lines, and then the brace wall panel support at your foundations. So a lot of stuff to cover. We'll start with just a basic definition. A lot of people trip up on this. So this is an important, laying out your braced wall lines is part of the art, but also part of where you can gain some real efficiency in meeting the code. But there's some art to it, and that starts to show up in the definition. It's a straight line through the building plan that represents, it not is, but represents the location of lateral resistance along a given wall line or facade of a building, or even through an interior series of walls in the building. And it's generally, you're going to have all your exterior walls or sides of the building are going to be identified as braced wall lines. And then the question becomes, do I need to kind of fit in some interior braced wall lines so I can have enough window openings on a given wall, or it's just I'm in a high load area, I need that interior wall regardless. Those are decisions that you would make along the way, and it's one of the first decisions you make. The code gives some ideas of how the text plays out on a couple example plans. The right being the upper story of a 2-story plan. You see that's a fairly simple box, and so there's 3 braced wall lines front to back, and just 2 that are required left to right on this plan on the upper story. So fairly simple. The bottom story has got more of an L-shaped pattern. It's got a garage exterior wall that then turns into an interior wall, and you can see the actual interior wall that this braced wall line is representing. The actual interior walls that are going to be designed either with a gypsum bracing system, or sometimes you even have to add structural panels to the interior. They're not actually on that wall line. Some people say, well, that's imaginary. I said, exactly. But it's imaginary to the extent that it represents these walls. They're close enough to it. So as long as they're within 4 feet of anywhere you draw this braced wall line, then they are considered to be represented by that braced wall line, that dotted line through the plan. And you can see the actual 2 interior walls may be separated from each other by as much as 8 feet. But if that wall is right in the middle between them and lines up with this wall, then they can all be grouped as a single braced wall line. There's advantage to that. And then because now you don't have to locate braced wall panels within each of those segments within certain spacing requirements that the code has. So you can see here the same thing's done on this back wall in this building. Braced wall line 1, the left to right or east to west braced wall line is capturing all these jigs and jogs in the braced wall line, but its actual dotted line doesn't align with any one of those portions. So a lot of people get tripped up on that. Sometimes even code officials say that you can't do that, but the code clearly you can do that, and there's good reason for it, because we're representing the net effect of all these closely associated wall lines that are oriented in this direction to resist wind load that's pushing on the building from left to right, or seismic response. These braced wall lines can only be spaced a maximum 60 feet apart to be in the prescriptive scope for wind, and 25 to 30 feet with some exceptions to go more in certain conditions for seismic bracing. So it requires you to break up your building and provide some walls of resistance, and not become too huge and then fall outside of the scope of the way these provisions were put together. Braced wall panels, that's a full height section of wall, from plate up to that plate, or from floor to ceiling. It's not interrupted by openings, so it's able to drag the shear force from the top plate and a floor or roof above down through the framing system into the bottom plate, where then it's transferred into the next assembly below, whether that's a floor or foundation. So it's got to be a full height panel, and that's what provides the racking or shear resistance to a braced wall line. Braced wall panels are constructed using one of the many bracing methods that we'll talk about later. Here's an example of how they would get laid out on these wall lines, the front and back, left and right wall lines that are folded out, so you can kind of see them in plan view, what those walls look like. And you can see this one back here has 2 braced wall panels. The braced wall panel has to be at least 10 feet from the end, although you can get around that. You can space it further. If you hire an engineer to just look at the collector up here and make sure you're not overloading your splice joints or whatever in your top plate, you can get around that. But that's a prescriptive limit in the code. And the braced wall panels, for the sake of having a uniform distribution of shear resistance going down to the foundation, they have to be spaced apart no more than 20 feet max to be within the scope of the prescriptive code. Again, if you run into a problem with that, there's ways of engineering around it. You would have to have that particular portion engineered. The width of the braced wall panels, depending on the bracing method, the minimum width you need to meet. But obviously, most of the time, you would fill that entire width with a braced wall panel, and you would just have more bracing than you need. And again, the amount of bracing you need on a braced wall line depends on where it's at in the building and how big the building is and what your wind and seismic loads are. But this just shows the basic requirement for how you've got to meet in spacing the panels that you are using, the braced segments of the wall along the length of a given braced wall line. Continuous sheathing also has to have braced panels within its length between window and door openings, even though it's continuously sheathed above and below. But that continuous sheathing above and below the openings is just to make sure those brace panels are anchored a little better and provide a little higher strength. That's why you get the advantage out of the continuous sheath. It creates more of a system that helps anchor these panels that are actually the portions of the wall that are dragging the resistance through the wall assembly. All right, so and in fact, the continuous bracing method was based on research that I had done to develop that methodology and bring it into it was brought into the first draft of the International Residential Code. Minimum required length of bracing per braced wall panel. So you have to basically there's a set of tables. These are pre-calculated that are tabulated bracing lengths. Those are sort of tabulated for standard conditions, a standard kind of roof slope or roof height above, eave to ridge height, a standard wall height, so that we can calculate bracing amounts for a standard set of conditions. But if you've got a lesser roof slope or a greater roof slope, there are adjustment factors you need to apply. And they can actually help you. If you've got a more efficiently designed building, or say you have 9-foot story walls and 8-foot story walls in the second story, there's a factor that would then reduce your bracing amount required because you've got less wind or seismic load based on the actual configuration. So those tabulated bracing amounts, that is your starting point, are somewhat conservative. Many buildings, there will be adjustment factors you can apply that would reduce your bracing amounts needed. And we'll look at that a little later. As I mentioned earlier, only wind bracing needs to be checked in the low seismic categories, what are known as seismic design categories A, B, C. For townhomes, however, in this moderate seismic design category C, you would also need to check seismic bracing in addition to wind and find out which one actually requires more bracing in each given wall line. So a little more work when you get into the high and moderate seismic areas with townhomes. And then for single family homes, that seismic check only kicks in when you get into the much higher seismic conditions, which are known as seismic design category D. And that's sort of broken into 3 different levels, D1, D2, and D3. But we don't need to worry about getting into that today. So here's an example of the tabulated, sort of the default basic bracing amount values for all the different bracing methods listed here in the columns of the table. So based on your building configuration, let's say you're looking at the top story of a 3-story, top story of a 1-story, or the story of a 1-story building. Then you would look at these category of rows to determine your bracing amount. Let's say your braced wall line spacing between 2 braced wall lines in a given plan direction that are sharing load is 30 feet. You would look through this row, and if you're using, say, a wood structural panel, intermittent panel spaced along the wall, not a continuous sheathing, then you would need 5.5 feet minimum of bracing. The code also says you need a minimum of 2 brace panels. So, and the minimum brace panel is 4 feet, so you actually end up with 8. So, but this is your minimum bracing default amount to which you apply some adjustment factors that are in this table. And you could end up with more than 8 feet with all these combined adjustment factors, or less than the tabulated amount, depending on your building configuration. And so the adjustment factors fall into 8 different types in this table, depending on your conditions. They address wind exposure, which has a huge effect on your bracing amounts, up to 50%. The bracing provisions are actually based on sort of exposure B, which is the more conservative kind of protected condition. But that's where, probably 70 to 80% of homes land in terms of in the middle of a development or a mix of trees and development. But if you're in a more severe open exposure or a waterfront type of exposure, then there's going to be some increase in bracing. Roof eave to ridge height, as I mentioned, the roof can have a big impact on wind loads, particularly on a 1-story building, because half of your wind load or more can come from your roof. So there are adjustments to account for that here in the table. Story height, same thing of your walls. The number of braced wall lines also affect the amount of load that goes to each braced wall line. some people see that as counterintuitive, that the way we're doing that, but the reason we're doing that is because we're considering equal shared load to braced wall lines, not a tributary geometric distribution, because that's traditionally the way engineers have handled it, but it's not right actually. These buildings act as rigid diaphragms, and the load gets distributed on that basis to wall lines. So these adjustment factors for braced wall lines were needed, and in the end, you come up with a more efficient answer in many cases than what an engineer will give you with a traditional sort of what's known as a tributary area load assignment. Then hold down brackets are there for a couple of reasons. One, for intermittent brace panels that are kind of acting alone as an individual brace panel, and you may only have foam or a non-structural fiber board next to it. That panel, then if you add some restraint to it to give more restraint and overturning, like just a simple 800-pound hold down bracket bumps up its resistance capacity quite a bit. And that then reduces the bracing amount that's needed. So you get some benefit by adding just some modest hold down brackets. No interior gypsum finish. All the bracing methods are based on having interior gypsum finish on the walls installed to the finish requirements. And that's because interior finishes have a huge impact on the lateral performance of buildings, as much as 50% or more of their capacity, particularly once you've had windows and doors and all the siding installed. It can dwarf what you consider your engineered systems. That in part is somewhat accounted for in the IRC. There's some system effect that engineers unfortunately can't use because it's not in their standards, but it's a real effect on these building systems. Is somewhat accounted for in the IRC's provisions, but gypsum is assumed as a baseline condition to be on the interior side of the wall. If you have a garage without gypsum or some other application, then you'll need to apply the gypsum adjustment factor, and you're going to bump up your bracing amounts to sort of account for the gypsum not being there. There's also the benefit of using a gypsum as a bracing method itself. And if you increase the fastening from a minimum 7-inch on center spacing for the basic gypsum bracing method to 4 inches on center, then you can get a little more capacity out of your interior braced wall lines with just gypsum. And this gets you, this can be very beneficial. I've had to actually do this on some houses that were built wrong because the bracing wasn't planned ahead of time. And this provides a simple solution just by adding additional fasteners to gypsum that's already there, remudding the wall, and you're good to go. Doesn't get you out of jail free all the time, but oftentimes that helps. Better to plan that in while you're designing and putting your plan forward than later. But there's just a lot of flexibility in these provisions. It makes it look complicated, but it's really not. And I'll show you the basic how you apply these factors. The same thing for seismic bracing. Here, though, instead of braced wall line spacing, it's based on the braced wall line length, because the seismic load is based on the amount of mass, not the area of the surface of the building, but the amount of mass, which is more floor area oriented. So it's based on the depth of the building and the load direction, which is represented by the length of the braced wall line. So just a different parameter, but that's what you use to pick your seismic bracing. And otherwise, you go in and you get your default number. And then you go to your adjustment factors for seismic bracing, which are different. Some of them are similar, but they're different. They're sort of more mass-based because we're dealing with, it's mass that creates the load. If you have zero mass in your building, there's no seismic load. Force equals mass times acceleration. Isaac Newton figured that out, and it still stands true today, even in building response to seismic. So that's what these factors account for, is different things related to the mass of the building that would affect how it responds and how much bracing you need to take care of your seismic loads. So here's the basic formula. If you can do multiplication, you can take care of all those adjustment factors. People don't like multiplication in prescriptive code, but to do bracing correctly without making it ultra conservative, and therefore in many cases not able to be used for homes where you want to have windows and doors in them, you have to have some math. And basically it's, you just take the tabulated amount required for the bracing method you're using, and then you multiply it times each adjustment factor, times adjustment factor 1, times adjustment factor 2, times adjustment factor 3, whichever one is applicable to the geometry and conditions of your building that you select out of those adjustment tables I showed you. And they're all cumulative. So you just keep multiplying until you've multiplied your tabulated bracing amount by all of those adjustment factors. Some may be more than one, some may be less than one. And in the end, you come out with the bracing amount that's needed for that braced wall, particular braced wall line on your building. And then you just have to check to say, okay, do I have that amount of bracing on that braced wall line with the bracing method I'm using and the braced wall panels the way I have them laid out and the windows and doors are arranged? And if it does, then check you're done with that braced wall line, you move on to the next one. So it's simple. It's a simple accounting process, but it does require you to look at the details of your plan and each braced wall line and go through this process. Now, one of the things you have to do is choose your bracing method, and there's advantages and disadvantages to each bracing method. And depending on where it is in the building, is it an interior wall line or exterior? Are you trying to use a bracing product that has multifunctional, or are you doing things, the old fashioned way with this product does this product does that, this product does this, and building up your wall assembly that way? How much strength do I need? The different bracing methods have different strength, and that'll show up in the bracing amount that's needed. The weaker method is still a good method, and it may have advantages for other reasons. You just need to have a little more space on a wall line to do that. A lot of end walls, a lot of interior walls, particularly walls separating garage and indoor space. There's plenty of space there, excess space for bracing, and some of these methods are maybe more economical there. So use those on those wall lines and use a different bracing method on a different braced wall line. So the bracing methods are sort of divided into two basic categories, some of them using the same material, but they're applied differently. Intermittent bracing means you're just going to apply different panels like at different places on the wall, or it's not even a panel, it could be a lead-in brace with gypsum on the interior side, and they have to be applied to different panels or segments of the wall. And in between those bracing methods, you could put anything non-structural you wanted to, because you're just relying on those intermittent panels, not the continuity of a continuous bracing. And this works for a lot of walls and has some advantages. So there's multiple ways of doing that with different materials, the intermittent bracing approach. And then there's a couple more intermittent bracing approaches that are actually narrow panel approaches, or are treated that way. So they can be used with intermittent bracing systems on other parts of the same wall line. And then there's a host of or four continuous bracing methods that use either wood structural panels or structural fiberboard, which is not your just regular insulated fiberboard. It's a little higher density, you have higher connection requirements to get your shear capacity out of it. And then, as we mentioned earlier, based on the strength of these systems, you can make, and the strength of an alternative or proprietary system, you can make a direct substitution or an adjusted substitution, an additional adjustment factor to account for the strength of that system right into the prescriptive code and substitute it for one of these bracing methods. So there's 16 in total, and 7 variants actually use wood structural panels. And of course, we see that being used a lot in practice, but there's a lot of other methods. And in fact, traditionally, 20, 30, 40 years ago, when I was building and in the construction industry, what we saw a lot of were just the old-fashioned lead-in braces, still with just the gypsum on the interior as you're bracing, and on the exterior, if you were in the north, you were using foam as part of the first sort of energy code advancement, after the oil crisis in the 1970s. So, but that's faded away. I mean, that's kind of been a loss in many parts of the country. They still do it some in Canada, but that's retained here. It's still available to do that. Intermittent bracing methods, as I mentioned, you have them spaced along a wall, continuous. You sheathe. Now we're talking sheathing systems, the entire wall area, but including above and below windows, and also in certain cases around corners to get the restraint. But if you want to switch to intermittent bracing on the wall around the corner for the loads in the other direction on the building, We'll get into details later where you can use a panel just at the end of the wall that's a little wider, or this 800-pound hold down bracket for no other reason than to provide the same restraint a wrapped corner would provide. Whereas in that product we saw earlier, they actually provide you with a wrapped corner element, which is pretty cool.
Jay, this is Jack, just to let you know where you are. We have 20 minutes left, so
Okay.
doing great.
All right, very good. I'll try to, I actually probably need to speed it up a little bit. So you can mix bracing methods. Of course, you can mix bracing methods from story to story, use a different bracing method on each story. You can mix bracing methods on a given story between braced wall lines. For example, you can use gypsum bracing method on an interior braced wall line on the same story that you have a parallel wall that's an exterior wall that's using some other bracing method. Within a wall line, let's say you have an interior braced wall line that in the interior building that's braced with gypsum on both sides, but as it goes to the exterior and becomes an exterior wall, it has another bracing method on it. As long as in that case, the total bracing amount along that wall is based on the weaker of the two, let's say it's the gypsum in this case, and you meet that amount, then you've satisfied the intent of the code. In fact, it would be a little stronger, but that makes it simple to mix different bracing methods and have a design that's very practical and efficient. So those rules are built into the code for that purpose, to allow that to be done, but also to provide some limitations where you can get into problems with incompatibilities in the rigidity, or I'll say brittleness and ductility of bracing systems. In the higher seismic areas, there are some additional limits on not being able to mix bracing methods in some cases. So now when we talk about the different bracing methods, and I mentioned earlier that each braced wall panel or segment of wall that has a given bracing type on it or method on it, there are certain criteria and the width of that full height braced wall panel for it to be considered counted, contributing length, it says here on the right-hand column, to actually be counted as contributing some length to the length of bracing that you calculated or figured was required for that wall line. So, if your diagonal wood board or wood structural panel or structural fiber board or your particle board sheathing or your Portland cement, you can use Portland cement. It's one of the strongest bracing methods in the code. The old-fashioned 3-coat Portland cement. Your brick veneered bracing method, which needs to be used in higher seismic areas if you have brick veneer and it's a heftier wood structural panel fastening and anchoring that needs to be done. But if you're using any one of those, each bracing segment that you're going to count its length as toward that required bracing amount you calculated, it has to meet these minimum lengths along the wall or width of wall segment to be counted. If it doesn't, unfortunately, you can't count it. Now, I won't get into it. There is a separate table that gives you partial credit because, gee, what if it's not 48, it's 36 inches? I know I'm still getting some strength out of it. So we did add some flexibility in a separate table that under certain conditions, on an 8-foot or 9-foot wall, you can skinny that down to 36 inches wide and still count some bracing, but you're not going to get the full 36 or 3 feet of actual contributing length. There's sort of a little bit of a penalty there, but that's the flexibility that you even have in the intermittent bracing method to make that work in some moderately challenging conditions. And that would apply to substitute materials that are shown to be at least equivalent to any of these. And then there's an alternate brace method, which includes hold down brackets and all of those on each bracing method that have also minimum width requirements for each panel. The continuous sheath garage opening also has minimum width requirements for those garage, wall segments between the garage opening. And then the continuous sheathing is a little more complicated, but this is important. So just because you continuously sheathe your building doesn't mean you get out of jail free. That it's not a simple button. You still have to meet these minimum panel width requirements between openings based on the opening height. Otherwise, you will not get the performance out of that wall system that the code intends. So, based on the clear opening height in inches next to a given wall panel, whether it's a door or window opening, you take the worst case. So if it's a door opening, it's going to be around 80 inches or so, 82 if you add your rough opening size. You need your panel next to that needs to be at least 32 inches wide if you're 8 feet wide. Otherwise, in your continuous braced wall line, you can't count the length of that panel as contributing. Okay, doesn't mean your wall doesn't have enough bracing elsewhere, but you have to check each panel. Here's an example of some portal frame methods. Lots of fastening, sometimes some extra hardware depending on the method you're using and the strength you need and the width of panel that it allows you to get away with. But you have to follow those procedures found in this section of the code depending on which method you want to use. And I'll leave it at that. Your corners of continuous bracing methods, you can do that sort of where we started that method out back in the first 2000 edition is wrap the corner with the minimum 2-foot return panel. That's easy to do, but sometimes you want to switch to a different bracing method on the other side. So we've added this minimum 800-pound hold down bracket at the corner. You can eliminate this corner return panel and switch to another bracing method. That can become pretty handy at times. Or you can just use, instead of the minimum 2-foot wide panel that is required for the continuous bracing method at the corners, even though it may not be a contributing panel because of its width and the window height, as we saw in the earlier table, it still anchors the corner. But you could just switch up to a 48-inch panel and not have the corner return and have the same effective restraint at the end of the wall. So lots of options here, even moving that restraint from the end of the wall line and sort of creating a false anchoring end by having that hold down bracket put to the other side of a window or door that's right at the corner. And then that becomes the anchoring end of that continuous sheet braced wall line. So lots of flexibility there in the detailing. This is just showing, a simple 800-pound hold down bracket. There's a number of options that you can do, and even post install if somebody forgets to do it, or if you just want to do it that way, post install, because it's easier to locate the anchor in the right spot on the plate where the stud is that you need to anchor. That's one of the ways you can get that 800-pound bracket. You've got to be concerned about detailing your wall connections and to floor and roof assemblies or ceiling assemblies. There's multiple ways of doing that. If they're not aligned with the joist framing, then you need blocking to have the correct fastening, and that's all prescribed in this particular section of the International Residential Code, R60210.8, which deals with that brace wall panel support and connection conditions. Same thing with if you're on like a partial height foundation wall, say at a garage opening or something, and this is a braced wall panel above, then there are certain anchoring requirements on that stem wall to make sure that the loads then go down through the stem wall and get into your foundation. All right, a lot to go over there. This is an accounting table that you can use to kind of put what I mentioned into a stepwise process. Step 1, lay out your braced wall lines. Make sure you meet that 4-foot offset allowance for that wall to represent a series of actual walls that are closely aligned, but not exactly aligned. Then step 2, you look at, document what's the support conditions, how many stories and a roof above am I supporting, because that's going to tell me where I go into the table to pick out the bracing amount. What's the spacing to the next braced wall line, or if it's a middle interior wall, what's the maximum of the 2 spacings of the parallel walls to either side that are sharing the load, or the code allows you to take the average, which is what I normally do because that's, I think, a little more accurate, not quite so conservative. And that's your braced wall line spacing that you pick your tabulated bracing amount from. Of course, you've got to pick a bracing method that determines the amount of resistance you're getting out of the bracing method, and that affects the bracing length required. Then you get your tabulated length out of the table, and then you adjust it by that simple equation, multiplying the adjustment factors times the tabulated length. And then you check, does it what your total required length is, and then you check that versus what you have on the wall. If it doesn't meet it, you got to adjust some things. Go back, make those adjustments over here in your counting sheet, check it again, you pass, you're done and good. Then the only thing is, are my brace panels within 10 feet of the corner? And this is an old number here, 12.5, it should be 10. Code used to be 12.5. I think 12.5 is fine, but it changed to 10. And then the code used to prescribe a spacing center to center of brace panels, but that was changed to 20 feet between, which is easier to measure and observe braced wall panels, because the center distance depends on the length of a particular braced wall panel itself. So anyway, you check those things out, all checks out, you're done. You move on to the next brace wall line, enter the information from the plan, and go through it. It's pretty straightforward. You can actually get pretty fast at this once you've gotten used to it, and you just have the plan laid out in front of you with your sort of braced wall lines. Oftentimes I'll use a magic marker or a highlighter just to lay out the braced wall lines, and then just immediately start inputting onto that accounting sheet manually. And after you've done it a few times, it does not take long, particularly in a simple building like this. It's a matter of minutes to input the conditions, like the spacing, 31 feet front to back, 44 feet left to right. It's a one-story building supporting a roof only, bam, bam, bam. Pick out your adjustment factors from the table and run your check, and you're done. This custom plan, a little more complicated, and how you break out your braced wall lines. You've got more choices there. So sometimes you say, well, this looks like a good choice for me to start with. I'm going to run with this unless something in my analysis shows I would have been better off adding another wall line, or maybe shifting it a little bit to bring something that was close to compliance but barely out. And you'll develop a feel for that through practice. And so this one, has 5 braced wall lines in either direction. Sometimes you might have 3 in one and 5 in another. And sometimes you might have 7 in one direction and 2 in another. If you've got a long row of townhouses and you're treating it as a single building in terms of addressing your wind loads, which is an advantage to do that. But there's a case where you might have many wall lines through the depth of the buildings. Some of them separate, fire separation walls, but only, sort of 2 major wall lines running down the sides of the buildings, even though they'd be individual walls in the terms of anchoring them, because you've got fire separation between one unit to another. Viewing it as a single building is the way the loads are going to actually happen, and it gives much efficiency in your design and applying the prescriptive provisions. It's a little trick there. So you select your bracing method, as I talked about. You select your tabulated bracing amount, as I talked about. You then pick all the applicable adjustment factors out of this table, as I talked about. Same thing if you have to do it for seismic. Then you check all your brace panels and add up the contributing length based on the direction that's given in this table and the width of your individual panels. And then every qualifying panel that has a contributing length, you add those lengths up. Sometimes you have to, if you just got, say, gypsum on the interior side of an exterior wall, and that's all you're relying on bracing, you actually have to, have the contributing length. It's like the same thing as doubling the bracing length needed, because if you leave out the gypsum bracing on one side of the wall, you have the resistance of the wall. So follow these procedures here and do the math as I've filled out for a particular building, all the details for a braced wall line, did the math, check the bracing length I provided, and just put in here, hey, that's well more than what I needed based on the calculation and the applicable adjustment factors. What I have in qualified brace panels meets it, so that's okay. I checked the spacing requirements, it's okay. I've got at least 2 panels, so I meet the minimum bracing requirement regardless of the length that you calculate. So everything's good to go on that wall line, and you just proceed through every wall line, each plan direction, each story level in the building. So you might have, a table that's several pages long, depending on the complexity of your plan. And as I mentioned, you're verifying the brace panel locations. And that applies to continuous and intermittent bracing methods. You're going to verify your corner return if you're using continuous sheathing, and regardless of your bracing method, your anchoring and interconnection to wall and floor assemblies. And just as a reminder, please don't forget the wind uplift load path. That's the demise of many buildings, not bracing, but the wind uplift load path. And if at first you don't succeed, like if you're checking a braced wall line and it doesn't quite work, maybe shift to braced wall line openings just a hair if the architectural design allows you to do that. Maybe reduce the braced wall line spacing a little bit by adding another interior braced wall line to the design. And then sometimes that's just a matter of declaring it because the wall's already there. So I'm just going to go ahead and declare it. Now it's going to have the fastening on the gypsum to be actually a gypsum bracing method and not just merely interior finish that supplements the bracing on the exterior wall. Sometimes you limit the offsets so that an entire wall line fits within that 4-foot allowance for offsets, and then you don't have to have 2 separate wall lines along a given side of the building and then different endpoints from which you have to space the required spacing of panels, which then sometimes adds another panel that you don't really need from a bracing amount standpoint. So if you can get those offsets so that you can call the entire wall line a single braced wall line, then that'll make a wall line pass without any other change than that. So there's lots of options you can do, but if you run out of options or it's obvious, you might need to have that portion of the building engineered. And
Jay,
so
just a quick time check from
Mhm.
the voice of the timekeeper.
Yes.
We're about 10 after,
Okay.
so maybe 8
Sure.
minutes left.
I think I'm almost there. Thank you.
Great.
Good reminder. So there are alternatives to use. I've mentioned some along the way. You can have an engineered solution where you've got to design, an engineered brace wall line, locate hold down brackets, get the nailing pattern on whatever sheathing the engineer is specifying. The engineer is going to stamp that, and that has to be stamped for it to be approved by the building official. The other approach is to use an alternative bracing method that has an evaluation report that already has the prescriptive substitution rules for it to be used prescriptively without an engineer. It's just the only thing that needs to happen is it be approved as an equivalent alternative. So you may see an engineer stamp for that purpose to have shown evaluation that it's an equivalent alternative, but you don't need to have that engineered stamp on every application, on every plan, because it's an approved alternative to the prescriptive procedures in the code that the code has always allowed to be applied by a builder or even a homeowner that maybe thinks they know what they're doing. That's just a right that the residential building code allows to the builder, and also building owners, as traditionally have had the right to build their own house. They just need to do it right to the code. Okay, so and then of course, you've got these multifunctional options now that sort of add a whole new dimension to integrating bracing decisions with energy code decisions and moisture control decisions, and kind of bringing that together in one package. And I think that's sort of the beauty of the age that we're in, with new technology and also improved codes and understanding these functions and how to guide them, that helps then guide innovation in products that are coming out on the market, like these multifunctional insulated bracing panels. So having said all this, it sounds like a lot. Even though the math is simple and concept is simple, there's a lot of accounting that needs to be done. So I've worked with a programming group to take this accounting process and the code requirements and put them into a free online calculator. It's now actually just a couple weeks ago been released. It's been through beta testing, and you basically can log on to it here at this URL. It's free to use. While it's shown to be at continuousinsulation.org, a requirement I have for any client is, this is not meant to sort of get an angle on the market, but help the market make a better decision. That means it needs to be generic, not product specific. It could be used for specific products, but this gets you answers that you can then make your own decision about what products to use and know that you're using them in a code compliant way. And you just put in your project details, the basic details that kind of framework some of the major factors or adjustments that are going to be considered to the project to fine tune it to comply with the code. And then there's a tab here that's not showing that you would go through then and input as many braced wall lines as you've defined on the plan based on your braced wall line layout. And it will, you select the bracing method, it will also show you alternative solutions. So if you say, oh, I could have used an alternative there, it'll show those solutions to say, if you want to change it, this other one actually does work. So it gives you more flexibility to optimize your designs in real time as you're doing the design and documenting it. In the end, you can press a button to get a PDF report that then lays out all the braced wall lines, all that you did in your entries to show that it complies with code. And you can hand that in with whether you're an engineer or not, as a means to demonstrate compliance with the code. It's a very handy tool to use, and I encourage you to give it a try. And if you find something about it that you think could be improved, there's sort of a survey button you can put in and enter in what you thought about it and what you think maybe could be improved. But that's there to help go through all these steps that I just laid out. In fact, I use it now for my own design. In fact, I've gone back and rechecked a couple old designs and found a few math errors that, I mean, they weren't non-conservative errors, thankfully, but it is easy enough to make some errors in trying to keep account of all this stuff. So this tool is really a big help as long as you input the information correctly, right? It's any tool is garbage in, garbage out, but this really helps you document it and then transparently see what you did in the end and easily edit it if you need to. There you go. So here's a bunch of additional resources that you might want to look at. If you're a real geek and want to get more stuff on the wall bracing provisions, there's a guidebook that's put together. It's about 90 pages long. You will also get a copy of this presentation that has a lot more detail on the slides than I shared verbally. There's a residential structural design guide that I wrote back in 2000 for HUD. That gives you a lot of engineering tricks if you're an engineer on how to do rigid diaphragm design and also how to assign what I'd say correct bracing strengths and account for some of the system strengths that the residential code recognizes now, but the engineering standards don't. There's a newer edition of this guide, but they've removed a lot of the guts that was the value, I think, of the original edition. So I would encourage you, both are good guides, but I would encourage you if you want to get some of those tricks and data and information on system effects, then you'll need to get the original edition of that guide. HUD republished it later with a different contractor. A lot of it changed. The right size wall bracing also is a helpful fact sheet. Simpson Strong Tie has a calculator that's good. It's agnostic. And it does also, if you run into a wall line that doesn't comply, it will kind of refer you to some of their pre-engineered high strength bracing systems, which sometimes you just plain need, even if you're using some other alternative bracing product, and you can integrate that with your system. So a lot of good resources there, and I appreciate your time. I look forward to hearing the rest of the presentation myself, and then joining everyone for Q&A at the end. Thank you.
Thank you, Jay. That was an incredible amount of critically important information. And everybody, please know that we will be sharing this presentation. It will be on demand as well as the additional resources. So this concludes the AIA approved portion of this program, which is always non-branded. But we're going to take a moment now to briefly review the barricade building products systems that they generically refer to in their program. And then we're going to go to that Q&A because we see there are quite a few questions that we have. We will ask Darcy to once again join us. Darcy, can you hear us?
I can.
Okay, great.
All right. Thank you, Mary. Hi, everybody. I'm back. So here at Barricade, we do have a unique structural insulated board that I would like to share with you. So there are a few things that differentiate our board from other structural insulated boards out there. And I wanted to highlight those so you really know the differences between what we have and other products on the market. So the first thing that sets our product apart is the use of the thermobrace structural panel as that engineered structural sheathing component. So our panel is a wood fiber panel using virgin wood fiber. So if you're going to have a SIB board with a lightweight structural sheathing, ours is the strongest lightweight structural panel on the market. and it'll hold more shear than the other options out there. Secondly, we are using the BASF Neopore as the foam in the panel. So it's that graphite polystyrene that's not releasing or off-gassing and holding that R value over time. So very important. And last, our panel is reversible. So again, that's unique to Barricade. You can have the foam in towards the stud or out. And we see that most builders who use the panel like to turn that foam in, so you're not overdriving nails and staples. The foam is protected. Again, you're not leaning ladders against it. Those are the three very unique things to the Barricade panel. In addition, we also just launched our ThermoBrace SIB guard product. So this is the first product of its kind on the market. And what it is, it's a flat panel. It ships flat, but it has a pre-bent notch down the middle of it. So it actually stands up and your framers wrap it around the corner of a house or a building where you would normally put flashing. So instead of that flashing, you bend this panel around and it helps reduce the air leakage in the building. It's providing your continuous insulation now around the entire structure. And it's available in either an R3 or an R5 option. So with Barricade, we offer, with our SIB panels, a 30-year system warranty. So if you go ahead and use the seam tape, which would be used for the joints of the panels, we have that in either a 2 or 3-inch option. Sorry, next slide. So this is our seam tape on a 2 or 3-inch option. Next slide. In addition, we have, depending on whatever climate type you're building in, a window and door flashing. So either an asphalt or a butyl or a stretch tape for around the windowsill. We have those options. So basically the panel, the seam tape, and one of the window and door flashings would allow you the 30-year Barricade system warranty. And with that, I thank you very much.
So terrific. Thank you for answering some of the questions that were actually in Q&A. So if our presenters could go ahead and come back on screen, that'd be great. If you uninvisibilize yourself, turn the videos back on, and we'll go into the Q&A. So just a reminder, many of you have been diligently asking questions, and I've tried, this is Jack Armstrong, I've been trying to answer them as we've gone along. So if you go to the Q&A tab, there's 33 of the answers that are already done. And then we have 21 open ones, which was stuff I couldn't figure out on my own. So I decided, well, let's let the experts do it. So part of it, Darcy, was what you were just talking about. There were some specific questions around, first of all, how much does it cost? But secondarily, what are the thicknesses that are involved? And thirdly, about the nailing fastening patterns.
Yep.
So between you and Josh, go ahead.
Yeah. So the nailing pattern is actually printed on the panel so that the framers don't have to think about it. So it's every 3 inches, 3 inches along the perimeter, and then 3 inches down the studs, 16 inches on center. But again, there's nail lines on the panels. It's available in R3 and R5. The R3 is about 5/8 inches thick. And then the R5, it's 1 1/8, but it nets out right at about 1 inch. And then cost, I can't really speak to that. That would be through our distribution network. But if somebody would like to reach out to me, I can put them in touch with somebody who can get them pricing.
Very good. Thank you with that. And specifically around some of the detailed questions, there was one about, is this available in Canada?
Unfortunately, it is not at this time. We have not done the Canadian testing. So could you buy it and bring it over there? Sure, but the tests are not done, and we do not have a distribution network currently in Canada.
Okay. And also there was a question, about, and Jay, this maybe is kind of a code question. I've been giving you a little time to relax your voice there. There was a question around, well, I live in a city that's still on the 2018 code. What, how does this apply to me now with 2021?
Yeah, I mean, the bracing provisions since the 2009 edition have been consistent with what I just presented. It's just been some more flexibility and a few tweaks. I mentioned a couple numbers were adjusted by a couple feet or something, but in essence, what I taught today would apply all the way back to the 2009 edition of the IRC as far as bracing goes. There have been energy code changes. I think a couple steps in particular that would affect wall insulation levels. I think back in the 2010, it would have been the 2012 code made a step. And then just recently, the 2021 code has made another step. So if you're to cover more climate zones, so with improved thermal performance. So, the bracing that applies all the way back to 2009. And in my mind, it applies to even prior to that, because this is at least equivalent to those prior codes. And then with the insulation decisions, it depends on what climate zone you're in, but the 2021 code is covering pretty much the northern half of the country, with continuous insulation as kind of one of the primary options prescriptively to insulate your buildings and cut down on thermal bridging and control moisture.
Okay, very good. One of the questions too, Jay, was around the 1/8 inch gap between the panels. Is that the typical OSB expansion factor gap, or?
Yeah, that 1/8 inch gap is there to take care of material expansion and contraction. I mean, I've seen it done on projects I've done. You warn the framers, space the panels 1/8 of an inch. They pack them in tight. It happened that the panels came to the job site or were stored and picked up, got in an environment where they were very dry, and then you install them that way and they expand. And there's no way you're going to stop that from buckling and popping off the wall. So that 1/8 of an inch relieves, that stress that would form by packing the panels in tight. So that's an OSB kind of particular thing. Everything has some expansion and contraction, but different materials can handle it differently. And the propensity to buckle is also going to depend on whether you've got your framing at 16 inches on center or 24 inches on center. You're going to have a higher probability of that buckling if you don't have that gap on 24 inches center framing.
Okay, very good. This other question, and there's a variety of them here, but the question was around the reversibility. So does the bracing spec change if the installed foam is facing in versus out? Darcy or Josh or Jay?
It should. It should, but I to be honest, I haven't looked at their evaluation report. Sometimes, I've seen products developed with it either way, and obviously one of the benefits you gain from having the foam to the interior is ductility. We're not even counting for that yet from seismic resistance. I've seen that. I'm waiting for somebody to capitalize on that from a ductile response standpoint. But when you get ductility, you also lose some peak strength. So you've got to compensate for that by adding more fasteners. Now, their schedules, if they've been through testing both ways for seismic capacity, would account for, and the strength they assign should account for those different orientations of the panel. But all other things equal, if there's no change in fastening, having the foam to the interior should weaken the shear capacity.
Yeah, and it is covered in our TER. So there's allowable shear capacities in our TER, both in and out, and equivalency factors for both in and out.
As a follow-up a little bit to that, Jay and Josh, one of the questions was, have the fastening thicknesses been addressed with the exterior insulation to take into account for any additional shear? So I guess the fact that, the fasteners are longer.
Yeah, yeah. So fastening with the foam towards the studs, you currently do need to use roofing nails. So we're working on some additional testing because typically people do install the thermo brace with staples. So we're looking at staples and nails. So yes, has been tested with the both R3 and R5 in there.
Okay. And so you can tell we have a lot of really great kind of geeky engineers that love this stuff. So there was a specific question around at a 3-inch nailing pattern. Do you have to use multiple studs or a 3x stud to have enough surface area for fastening, 2 panels next to one another without splitting studs?
We have not had an issue with splitting studs. And yeah, it's you basically have each panel covering half of the stud there. And yeah, it's every 3 inches you put them in, no problems. If you do have a joint or a seam that is not at a not your sill plate or your top plate, but you have a seam in another location, you do need to add blocking behind that and fasten it to that.
Okay. And another kind of pseudo follow-up question to that, does the fastener penetration in wood stud change based on wind or load requirements? How far in the tip of the nail were fasteners going in?
Absolutely. Yes. So, I mean, the prescriptive code kind of gives you a minimum fastener embedment for an assumed fastener type. That gives you a certain level of wind load resistance. That's why I was mentioning earlier, that's one of the reasons why the IRC scope is limited for things like that. You get into a higher hurricane wind zone, and those fastener embedments that the code is assuming are no longer enough. So that's just the nature of having a scope limit to a code so that it's usable and not, it's already 4 inches thick, that, covering those high wind seismic conditions would make it 8-inch thick. And frankly, that's where you probably gain a good bit of benefit from having an engineer, professionally design the building, or an architect.
And there were some questions in the Q&A, some comments about, hey, where are the professional engineers in all of this? Shouldn't all of these be designed? And I said, well, it's specific to if you can fit the prescriptive criteria. Otherwise, you need the engineer.
It's a cookbook, and it's at the engineering pre-done, as long as you fit the widget within the mold that the engineering was based on. And yes, it's a little bit complicated with bracing, but that's why we have all these provisions out there. I know there's a lot of struggle with enforcement. There's a need for training. There's a lot of inconsistency and how this is being done. I'm seeing a lot of building designers. They're not engineers, but building designers that are smart folks and can understand this stuff. And they are becoming very proficient at doing these kind of, it's basically like a tax preparer. I saw one comment that said, this is like an IRS form. Man, it sure is. You are exactly right. It's a good analogy. But in this case, it's not somebody trying to steal something from you. Did I say that wrong? You're not paying your fair share of taxes. That's what I really meant. I apologize seriously for that previous comment. That is not what I meant. But it helps you to be compliant with a code that's trying to protect the consumer. And unfortunately, it's necessary because this is a fairly complicated. There's lots of factors that affect the loads on a building.
And one of the questions too was regarding the film on both sides. And so whether it's water resistant barrier on both sides, is there a problem about trapping moisture into the center of the walls? I think it's breathable. I think it's above a perm rating of 3, if I remember correctly. So it's not actually a vapor barrier. It's a water resistant barrier. Josh?
It is. So no, the water resistant barriers on the structural part of the board are, you know, if you're installing it out, it's going to be there. And yeah, there's not an issue with moisture being trapped in between the two.
Okay.
Well, too, yeah, I'll mention also one of the things that I've worked on bringing into the building code, a different chapter. It's the vapor retarder provisions, chapter 7, 702. We've got all the technology added in there that assures you get the right ratio of cavity to exterior insulation for a given climate zone, because that's one of the simplest and most effective ways to control water vapor. It's vapor movement that creates drying, but it's also sometimes when you open something up, when the vapor's flowing outward in the winter, it actually causes more moisture. So there's a balancing act there that has to be walked, and people get very confused about the building science. I've heard all kinds of oversimplifications of it and so forth. So in the code now, we have insulation ratios that are already pre-calculated with R whatever on the exterior, R whatever in the cavity. And as long as you're meeting that in this climate zone, you're good. And it keeps you from getting out, inadvertently stepping on a time bomb with moisture control. So one of the simplest ways is to get your continuous insulation right on a wall assembly to control not just your water vapor, but also your, not just your bulk water, but your water vapor and drying potentially.
Mary, this is Jack. Just as far as a quick time check, I think our presenters are happy to continue on with a couple of more questions. I wasn't sure if many of you have a hard time stop, but just some guidance there, Mary, for how much longer we can continue.
Yeah, so I was actually thinking the same thing. So we're at 1:36 right now. So we're in the after show, which is great for us. But I just wanted to, for those people who need to jump off, I wanted to take a moment to thank BASF and encourage everybody to visit neopor.basf.us. And if you have any questions about Neopor or anything that you have heard about here, feel free to reach out to us. We will be sending follow-up emails. So all of this information will be available to you. And also there are Neopor experts here as well, if anyone had any questions about Neopor. But for those of you who have to leave, thank you so much for participating, and we will be sending your certificates shortly. And hopefully we'll see you again soon.
Thank you, Mary, for that. So Jay and Darcy and Josh, let me know if you guys have another 5 or 10 minutes to maybe answer live some of these questions.
Absolutely.
Sure, let's knock them off.
Fabulous. So another question was regarding, they said in the table, says in your table, you show the same length of nails for both panel thicknesses. Is that right?
Yes. Yeah, that is correct. So it provides the 1 3/4 inch 11 gauge roofing nails will provide adequate holding power for both products.
Okay. And there was another kind of similar question. It was around with the new energy codes and continuous insulation, how can shear be transferred, or how can shear transfer be accomplished with the foam attached to the face of the studs and the structural sheathing offset to the exterior?
So the fasteners that are there, it's still going through the structural board and the foam. So it does offset it, and create a little moment there. But in all of our testing, we are still meeting requirements. So it's, the shear strength is still there. Yeah, the foam doesn't compress that much.
You make up for it by adding more fasteners. That's why they have a 3-inch center spacing. I mean, it just, if they didn't have the foam there, they could have the 6-inch on center spacing like you would an OSB panel. It's as simple as that. I've done a lot of testing of fastening through foam, even structural ledger connections through foam, up to 4 inches thick. And it's just a matter of accounting for it properly.
Yeah.
There was another question regarding about our little 1/8 inch gap and this expansion contraction, and it related to the tape. And is the tape available that you offer able to flex on that expansion contraction at the seams?
Yeah, the tape will move. I mean, it's bonded to both sides, but it'll gap. It'll, you know, sorry. If it expands a little bit into that eighth inch gap, you know, you may get a little pucker in the tape. But we have never, to my knowledge, had an issue with tape ripping or anything like that in
We have
between.
not, and also we recommend the 3-inch tape, so it covers more on each side of the panel.
Yeah.
And
Yeah, I've done a number of jobs with tape joints because I wanted to experience it. You know, in the 90s, I think there may have been some product out there that didn't work like it should have. But the products that are out here now and the adhesive formulation, the backer that's being used, by and large, I've been really impressed with the number of different products. I haven't used barricades, but just those tape products are pretty cool and have gotten easier and easier to install and more flexible. And frankly, we've been doing this technology on membrane roofs, which are far worse exposure than a water-resistant barrier in a wall where joints have been seamed together and slightly different technology, but I mean, essentially the same thing.
There was a question regarding, it says, can you use plywood bracing on the inside of the wall as well as the exterior side of the wall to make up when you don't have enough length of the required panel?
You're saying to double up your structural panel bracing on the wall line?
Yeah, I didn't quite, it wasn't
Yeah,
stated.
this is something that's a good question, and this is something that the IRC is not real clear on, and I think it needs to be clarified. The whole framing system, and remember I was talking about restraints, and all that's kind of a balanced system to the maximum capacity of the bracing methods that are in the code, the maximum shear capacity. If you're doubling those capacities, then you're doubling the need for the framing system's overturning restraint. And it won't be there if you don't add an engineered hold down bracket system. So while it seemed to make sense, oh, I just double the panel, I can have my bracing amount. There's no adjustment factor in the code for doing that prescriptively, because you will then force you will hit a limit before you get to the full strength of that double-sided wall with 2 layers of structural panels, and it'll be an overturning force limit. So that's where something you can do it, but you're going to have hire an engineer to do that. It's outside of the limits of the prescriptive code.
Okay. Actually, a question from Gord Cook. I don't know if this is the same Gord Cook I know, but perhaps. Says, is the structural component suitable as a nail base for cladding, or do the cladding contractors need to nail back to the studs?
So
It
for
is.
go ahead, Josh.
I was just going to say, it is not considered a nail base, and they would need to attach exterior cladding to the studs.
And is that regardless of the type of cladding? Or there was a question earlier about, what's considered heavy cladding? Is it cement siding versus, say, stucco versus, vinyl siding?
Yeah, it should. I mean, every exterior cladding I've seen, it says you either need to attach it to a stud or a nail base, and we are not considered a nail base. So yeah, you could attach it to the stud, and honestly, that's a best practice anytime. I mean, I know people install vinyl siding into OSB all the time, but that's not the best practice.
Okay. And there was a question also, is an inside vapor barrier still necessary since you have your your films on both sides?
So actually, on our product, when you turn the foam in, we allow the other barrier to be removed. So you have the weather barrier, the poly coating on the one panel And then you don't necessarily have to have the other weather barrier on the foam any longer, as long as that foam is turned in toward the stud.
Were they asking about a vapor barrier, not?
Yeah, it says, is an inside vapor barrier still necessary? I think that probably depends on your climate zone.
Well, it does. So in climate zones 0 through 3 in the south, you would not need one regardless whether the continuous insulation is there or not. The code allows that because of the vapor drive direction that's predominant. But as you go further and further north, if you say your maximum R5 on your exterior insulation and you've got like an R20 in your cavity, at some point, climate zones 4 and higher, you're going to need to have at least craft paper, which is a vapor, like a smart vapor retarder. It's the first natural smart vapor retarder. And then as you go further and further north into like climate zone 7, 8, if you look at those code provisions in the wall calculators I posted in the chat, that were the basis of the code provisions, you would need to then go to like a class 1 interior vapor retarder, and then to allow breathability, that needs to be a smart vapor retarder film at the far north, based on the insulation ratio. Now, if you had all exterior insulation, nothing else, then that's a condition where their product or any other product can be, you could put all your water control layers on the exterior and totally protect your structure with all exterior insulation, your WRB, your vapor layer, your insulation layer, all of that exterior can also be done. And that is enabled in the building code now. But it just depends, what climate zone you're in and what ratio of insulation materials you use. And if people don't like the complexity of that, then they can build buildings that melt down. And then that's what we've been having happen sometimes. And we've got stuff in the code now to keep people from getting in trouble, and both in bracing and in the moisture control stuff.
Okay, very good. Thank you. Darcy, there was a question about, does the warranty cover the tape?
Yes, so it's a system warranty. So should anything break down or have a manufacturing defect, yes, it would be covered.
I figured that was probably true. Another question was, how does exterior insulation, such as your SIB board, affect the bracing according to the prescriptive path for bracing? Would that determine if the SIB board is installed with insulation facing in one direction or another?
I'm sorry, can you repeat
Sure,
that?
just said, how does the exterior insulation, like continuous insulation like your SIB board, affect the bracing according to the prescriptive path for bracing? Does it change based on if the SIB board is foam inside versus foam outside in one direction or the other?
We do have slightly different shear values for foam in versus foam out that are covered in our TER. It's maybe a little more to get into right now, but yeah, there are different bracing values for foam in versus foam out.
So they can just check the report.
Yeah, okay. There's not a huge difference between them, but yes, it does affect it. The foam in is slightly lower, but it's not gonna cause you, it's still gonna provide adequate bracing strength compared to OSB.
For Josh, oh, go ahead, Jay.
I was going to say primarily because you have a different fastener and fastening pattern to account.
Yeah.
Okay. There was another kind of twist on that, saying, well, what criteria for fastening for siding to the panel? What is the criteria for fastening siding to the panel since it has such a thin layer of wood? Does it really just depend? Your recommendation was that you always need a cover board or an L base, right?
Yeah, you're gonna follow the siding manufacturer's instructions, and generally, with our material, you're gonna need to fasten it into the studs, and most exterior claddings that I've seen state that anyway. So
yeah.
And kind of a twist on that question, I think it's kind of similar. It says, do you have engineering on how heavy the cladding can be for a given screw or nail length?
I can answer that. That's already built in the code. It was something we foresaw coming back in 2010 or 2012 with the energy code changes. So there was a lot of research in NYSERDA and DOE, the steel industry. I worked with the wood industry, the insurance industry, and we put together a lot of testing to look at, how much can a cladding fastener take through this thick of foam or that type of foam, and what are the limits to doing that? What size screw do you need to use if you're putting furring outbound to the foam to attach your cladding to? And so all of that's in the International Residential Code now. It's also in the International Building Code for commercial buildings. And if you're lightweight cladding like vinyl siding, or frankly anything as light as fiber cement siding or less, which is about 3 pounds per square foot max, you can usually, particularly for up to an inch and a half foam, use the regular fastening pattern, and it's plenty to support the weight of the cladding.
There were
Just need to hit the stud.
Yeah. There were a couple of questions, Jay and Josh, about, excuse me. It said, it was talking about the BWL, I guess. So that's that bracing wall. So it says, how are openings treated in the calculation of BWL for the sim?
I assume, if you don't mind, I assume, and Josh or Darcy can correct me, but I assume your system's treated as a continuous sheath bracing method, correct?
Yes.
So it's treated no different than any other continuous sheathing bracing method in the code. The length of bracing you need kind of defines the limit of the length of wall that you can put openings and doors in, just like it does with OSB or any other bracing method. And that depends on, what's the space in between your braced wall lines, how tall is your building, how many stories are supported by that brace line, and all those factors. So any bracing method is going to run into, in the IRC, is eventually going to run into a building where it's exceeded the limits of that bracing method. And unless you change something about the building, you're going to have to come up with an alternative engineered solution. That's true of the barricade product or OSB or gypsum or lead braces, whatever you choose to use in the code.
To that end, Jay, the BWL, how does it align vertically from one story to the next?
Yeah, so of course, if it's a bearing load system, you're going to have to transfer gravity loads. So there are limits of offset for gravity load transfer, where you can't go any, I think, more than the depth of the floor joist and having an offset. For shear load, the diaphragms are capable of transferring those for the range of shear capacities of bracing methods. So it's mainly an issue of anchoring them to the diaphragm above and below. As I mentioned, there's detailing requirements to do that. And those diaphragms will drag load horizontally into bracing wall lines below. So there's not offset limits, although there are on the exterior walls, simply because of limits on the amount of floor overhang the code allows. And then if you're in high seismic areas, there are what are known as building irregularity limits. I didn't talk about those. They're in chapter 3 of the code, kind of a weird place, but it's kind of an overarching scope limit. So they put them there that, you can't have certain irregularities in the buildings, like misalignment of braced wall panels from one story to another in the high seismic areas. But that doesn't apply to the rest of the country in the IRC. Hopefully that answers. So there's a lot of flexibility there.
Yeah, there was another question regarding about what do you do about the nail or staple heads and the tapes and the sealants? Darcy or Josh?
So you don't do anything to them. So they're supposed to lay flush against the thermobrace panel or the foam. You don't need to tape over or seal in any way.
Yeah, and I mean, you ask the same question of any WRB, right? Some of them get riddled with staples all over the place and whatever fasteners, and they blow in the wind and rip a little bit. Obviously, it rips. You should repair that. But a lot of the testing I've been involved with in WRB tests, actually fastening through the foam gives a little more of a gasket to the fastener, has been my experience. So it's, at least in terms of comparison to other materials You're going to get a little better sealing around your fasteners. And I think, I don't know about your system, Barricade, but any foam product WRB system has to be tested to a much higher pressure differential than even just any building wrap or tarred felt or any other WRB membrane system. So and the fasteners are exposed during those tests. So
Yeah.
Yeah.
And we have done those. I think it's ASTM 331 where it's, the fasteners are exposed. We've done it board in, foam out, and it's spraying water, and it actually has a window in there and it pulls a vacuum on the back side. So if water is going to make its way through, it gets pulled through, and we'll do that. And we've passed all of that. So it's not an issue. And it's honestly never been an issue in the field that's come up either.
One question that I meant to do that it actually was answered in the very beginning. Michelle asked this. How about fire-rated systems? Can this be used in a fire-rated system?
That is something that we are working on. We currently don't have like the 1 and 2 hour firewalls in there, but it's coming. It's coming.
Ask for a lot.
Yeah, and the other thing is, in commercial construction, if we're stepping out of residential type 5, wood frame buildings that are they're made out of combustible materials. You get into type 4 through 1 buildings, like in the commercial code, then you also have to be concerned about flame spread. There's full-scale multi-story fire tests that would need to be done, and detailing when you have products like this on the exterior for those, steel frame, concrete, non-combustible types of construction to maintain their fire performance. So there's test methods that are out there that would allow the products to be used, and the manufacturers, are doing those tests of foam products. But I assume Barricade, you guys haven't done that yet. That's a fairly expensive test battery to go through.
It does get expensive. So
We're working
it's
on it.
yeah, it's in the docket to do it, but
Okay.
we just haven't gotten there yet.
Right.
But is this considered any differently than regular continuous sheathing that would be on the outside of the building? I mean, it matches what's
Yeah, it would be considered the same.
We're talking type 5 combustible wood frame. I mean, the very framing and structure itself is
exactly.
combustible material, so that the way of controlling fire, is, fire rated assemblies where you have narrow lot line differences, or you've got a fire separation wall. But other than that, it's fire detectors, fire sprinklers. It's not just the passive stuff. It's the combination of things that are used in wood frame construction, and building area and size limits, exit egress way requirements, all that control the life safety aspect of fire protection.
Well, very good. Well, Mary, I'm going to hand it back to you. We've gone kind of like almost 30 minutes in overtime, so people are definitely getting their money's worth from today's presentation. But Darcy, Jay, Josh, thank you for hanging out an extra 30 minutes. We still had probably 50% of the attendees still on the line now, so they've hung in there with you. So thank you, everybody. Mary?
Yeah, okay. So this was great. I mean, and it does sound like there's a lot more conversation to be had at another time. So please keep your eyes peeled for more programming from us. I know that we're working on another program with Barricade that has more case studies, so we can see how this system is used in the field, and real life working shots. I think that might be really interesting for everyone. And so also, if you have any questions about anything, you can always reach out to me, and my email address, I'll share that with you now, and I can get the information that you need over to you. But please know that we will be sending follow-up email with how you can watch this again on demand, how you can access all of those great resources that Jay mentioned, more information about Neopor, and we really look forward to the next time we see you online or in person.
Thank you very much.
Yeah,
Mary,
thank you.
quick question on the video follow-up.
Yeah.
So I know the Zoom platform, will they allow them to directly access the video via that? or you'll follow up with the
I will
email.
follow up, I believe so, but if not, we'll download it, we'll upload it to YouTube, but they'll be able to see the video again rather soon. Okay. Jack, you're muted, I think. So I think that unless anyone has any other urgent questions,
We can go ahead and
yeah.
close the meeting. Yeah, thank you, everybody.
Thank you all very much. Appreciate it.
Thank
Thank you.
Enjoy
Bye.
it.